Hello, I'm Asma. I'll be going over some explain integrations, which basically just show agent use case demos in real world applications. Yeah, so the objective is basically just going over some integrations with how a real world app would basically look like across a couple of platforms, being Slack, CoPilotKit, and Vercel. I'm going to be briefly going over two different agents, the JiraSense agent, which summarizes Jira updates and ongoing tasks, and a fitness chef agent, which plans meals and tracks macros based on user input. I'll be going over both of these agents shortly before I jump into the integrations. So for the agent integrations, we have three. Like I said, Slack with JiraSense, which just briefly, the backend has fast API, Redis, and Celery. And for local development, it has ngrok and Uber. And for production, I have it deployed on render. And I'll just go over that really shortly. I also have CoPilotKit UI integrated with the Fitness Chef backend endpoint, and that's local on ngrok with Ubicorn, and it could also be productionized with render. Finally, we have the Vercel web app, which is deployed using the explain agent endpoint in the backend. And it has Vercel. You can use Vercel templates or custom UI elements based on whatever your use case is. Let's jump into agent demos. So this is the Jira agent. Just confirm if you guys can still see this.
I can see it.
Okay, good. Just briefly going over this agent, it has two custom utility tools. So one is the search tool, which basically just goes, yeah.
Just zoom in a little bit, please.
Okay, good.
That's good. Yeah.
So the first one is the search utility, and this basically just returns based on the user input you provide. Like it searches for the user and returns things like the account ID, the display name, and the email address. And the second is the issue search utility tool, which basically based on your query that you asked, it finds the relevant issues and provides the result in like a JSON with like multiple values. So summary, issue type, the assignee, description, things like that. Also the project board that it's associated with. If there's any time tracking, it can handle that. And this is how it looks like in the agent. So these are a couple of questions that you can ask. Things like how many tasks were resolved, or how many bugs were reported, bugs that were fixed. And it works across these four project boards. So the bug tracking, product development, research and development, and science and engineering. Always combine into this JiraSense agent. And once you deploy it, you have your agent ID, but you also have an agent URL. And this URL is what we use for integration. So here are a couple of examples of how that looks. So you can ask it questions like this. What were Tiago's tasks in the first week of January? A couple more examples of the tasks that you could ask it. So the status of a couple of stories, how many bugs were resolved. And it's going to give you pretty extensive responses. Another thing you can do is go over execution stats that kind of cover a breakdown of how many credits were used and things like that, which could be useful for you. And now talking about integration, this is how the integration would look like. So you have something that looks like this, which is your agent URL, and this is what you would essentially integrate. There are a couple different things I'm going to be going over for the integrations, but this is how they would essentially look like in Python. Okay, so let's jump into the Slack agent integration. Let me just share something else. Yeah. Okay, so this might look a little overwhelming, but bear with me. I will try my best. I can just get this going. Okay. So here is your Slack agent. You can see my Python code, right?
Yes.
See my screen?
Yeah.
Sorry, I'm gonna keep asking because I have to keep sharing. Bear
No
with
problem.
me. Anyway, here is how the agent actually looks. So we have, let me actually start with main.py. So first we define our fast API. So we initialize a fast API, and that has endpoint just to check if the API works. And then we have the startup event. Basically, that's always going to have a Celery worker ready in the back end. And the Slack endpoint is basically every time you get ignore this because it's just like Slack verification, but every time you get a new message, it offloads to Celery. So Celery is just something that's allowing us to have different workers. And what this does is that prevents API from being crowded, and it allows us to, if you have multiple users and things like that, you don't have to wait because it's always going to be available. And also helps with Slack because Slack has this issue where it needs acknowledgement really fast, or it keeps like spamming with queries. That's where we're using Celery too, so it offloads the Celery. And now the task.py is where our actual agent works, is we initialize Celery with the tasks, and we use a Redis backend. What this does is that it uses it as a response broker, but also all your sessions are maintained over there. Anytime we get a text, we run our agent and we run it with a session ID being the thread ID. And the reason this helps is because it helps us maintain history, which I'm going to show you in just a little bit. Let me just jump into the actual JIRA bot. This is what the chat window would essentially look like. And you can have new chats, you can see the history and also brief about sections. So let's just start a new chat. I'm going to ask it one of the questions I have already asked it. I ran this a while ago. I'm going to also show you how the backend looks like for this agent. I also have this whole workflow deployed on render. So if I can just show that, you can see this. I'm good, sorry.
Yeah, no, it's okay. I'll let you
Yeah,
know if we
but
are not able to see anything.
okay,
Keep going.
that's even better. Okay, I guess you guys won't be able to see. So this is like the log. Okay, so this is render where I have deployed the application. It has two different aspects. It has the actual agent code and it has the Redis database. Oh, also the response is generated here. You can see that there are a couple of tasks, assignees, priority that's assigned, the project, any description and things like that. So you can ask it follow-up questions about these agents in particular, any particular task, any particular story that's currently going on as well. But coming back to render is actually really easy to use because you can just take all your code, deploy it to GitHub and connect it with your GitHub. So every time you commit or push a new change, it automatically deploys over here. And you have a log of how your agent is working. So every time you post a message, you have a post request. It starts one of the Celery tasks that I mentioned, and it tries to get the response. And once it gets the response, it'll just say that the task has succeeded and the time it took for the task to succeed. This is pretty neat, and because you're offloading these tasks, you can have multiple people use it at the same time without it being slowed down and things like that. That's JIRA. I will move to the second integration, which is the fitness chef. 1 second. Let me put everything I need for that up so that we have everything ready. Yeah. So I need that over here. This is the fitness chef agent. This is going to be used for two of the other integrations I showed today. They're more UI focused. Okay, so the fitness chef agent is an AI-powered assistant that helps generate new and innovative recipes based on available ingredients. And it uses a scraper utility. And what this utility does is that it goes to this website, which is naturalmedicines.therapeuticresearch.com. And it will return the protein content of different common foods. And it also uses this recipe index, and that is basically a Kaggle dataset of food.com that has let me get this correct, 200,000 recipes.
Asma, could you
Yeah.
slow down a little bit? It's probably a little fast for some people.
Yeah, no, absolutely. Just
The Jira Slack bot code, that's available on our GitHub, correct? The cookbook? Or not
don't
yet?
think it's available, but we could provide it after.
Okay, good.
Coming back to this, so you have a index, which is basically almost like a database for your to use for different, like a reference point. And that index has 200,000 recipes from food.com. And these are different, they have a bunch of different ingredients and they have all of that information there. And what we're telling our agent to do is to refer to that index for the searcher to refer to the index for like inspiration. And it always creates a unique recipe, and it always provides it in the form of having your protein breakdown followed by the unique recipe that the agent creates. But also it's going to provide similar recipes from the search tool index. So any two recipes that are closely matched in ingredients are going to be displayed here. We're using GPT-4o as the LLM. And here's an example of how that would look like. So if we have a protein goal of say 135 grams of protein, and these are available ingredients, This is how the protein breakdown would look like. So you have your ingredients, the amount of protein per 100 grams, and how many grams you're using in your recipe, the recipe, and then similar recipes as well. Once this agent is deployed, you could use this as an endpoint, like I mentioned. Here is how I'm using it as part of my application. So over here, I have a really simple chat interface. It has 3 different prompts. You can obviously put your own text as needed. And let's go with this one. And it always has the use explain that ask explain that comes up. And
Zoom on the app that you just showed. There we go. Okay.
there we go. Okay. I already zoomed in here. I didn't zoom in there. So here is let me just walk you through how this CopilotkIt works. So once you start CopilotkIt, you just start the integration with your API key and the tools that you mention as being explain. Ask explain comes from this logic where you have your agent started with the fast API, and you have a function where you basically just mention you have your post request and then you have your get request. And this is just some debugging and error handling that I have going on. And once you have a response, it produces the response. So now in CopilotkIt, you always initialize your code with actions. And what these actions are is basically you telling the CopilotkIt LLM to actually just use this action, to actually use this, which is what the tool over here is doing. .css is just the CSS for this, and I have some couple of prompts here, and a lot of these prompts are working here. Now, an interesting thing about the way CopilotkIt works is that it always wraps the input and the output in an LLM, which is why we always have, even though the prompt doesn't have ask explain, I have an ask explain over here and I have an ask explain over with the input over here, because I need to make sure that the LLM is actually using explain.
So,
Here is the log. Yes.
quick question. The ask is explain, is it like a token that you have to add so that like enter, or is it easy to differentiate that, okay, this is where the input starts or output starts? Because when you said that the input and output are wrapped together, so that's why I'm curious.
Oh, so yeah, CopilotkIt actually uses its own LLM that every time you put an input in, it rewords or restructures the response based on its own LLM. So even though the query over here looks like this, or what we put as the input, the query that it's going to send to explain looks like this.
Okay.
It kind of wraps it and rewords it. It has its own, once the post request is made with the API, it's waiting for it to poll before it gets the result back. Now, even though this is a really extensive result, you will see that the response over here is not that extensive. It's summarized and shortened to just be the information, a specific set of information. And this is because the LLM, again, restructures, summarizes, and gives you a shortened version of the response. So that is essentially how this works over here. Another thing that you need to do when you're using remote endpoints with CopilotkIt is actually go into their cloud. And before I get to that, let me actually show you. So we have an ngrok, like I mentioned, we have an ngrok server running over here, which provides us with this endpoint, which is the CopilotkIt underscore remote. So the Flask API and the ngrok put together over here. When you come to CopilotkIt, you need to actually upload your endpoint over here. I'm not sure if it's gonna load, but you need to basically upload your endpoint to CopilotkIt, Copilot Cloud, and that is the expose endpoint, which is basically what allows this to actually work. So this is a little bit more extensive and more well-rounded as UI, because not only can you have your own UI components, but it's also more bulletproof because it has these wrappers and it has these other things that you need to do to make sure your application works the way you want it to. Similar to Slack bot, you can also deploy your code over here on things like Render to host it if that's easy for you, but that's definitely an option that's available. So that has been CopilotkIt. Next, I will just show you guys, this one's going to be easier to show, but next we go over the Vercel. So Vercel is actually pretty neat because what it does is that it hosts your entire application. So your code again goes to GitHub, and every time you deploy your code, it auto deploys on Vercel. But another cool thing about Vercel is that you can also build on Vercel, and you can use these templates and just plug in the explain endpoints. And this is how the front end for this looks. This is slightly fancier because there are a couple more components on this. So you have the chat that we just saw. You also have an ingredient list that I have here, so you can just select things that are interesting to you, and I'm just selecting things. Okay. And you can get recipe ideas. And another cool thing is that you can actually go to protein intake, put in your daily protein intake, put in your weight, and ask for your fitness goal, and have this run a query to kind of give you recipes that are more in line with what your goals are. So here is a recipe. You have this kind of does not do the whole wrapper thing, so you have your entire response here. But another thing you can do here is go into the logs and look at the
Asma,
logs. Okay.
slow down even more.
Okay. So
Just
I
even
don't
more.
sorry, I'm just like a fast talker. I'm gonna try my best. So you can actually go through logs over here. So what you can, it received our message, it checked if the API key exists or if it's true, it's ran into it, it submitted it to the endpoint. And when you submit a post request, you get back your data through a result URL. So you take this result URL and then poll for the GET response. So you see the status being in progress, and it's going to be in progress for a little bit before it gives you the response till the response is completely generated. And that's what our response looks like. Pretty neat. And the best part about this is that that's already deployed. So you can actually just send this and you don't need to worry about hosting it after this. It's just that you have this endpoint or this domain available to you. Let's go through the explain
Quick
endpoint.
question. The endpoint, the after deploying that you get the endpoint, is that something that anybody with the link can use your application because it's already deployed on Vercel?
Yes.
Great.
Yeah, it's a very short response, but yeah, basically you take your endpoint and you can actually have people test it out, work with it, things like that. So here is the GitHub repository. Under in the API, I have my explain endpoint in this file.
Zoom
This
in.
might look slightly more overwhelming because zoom in. This might look a little overwhelming because it has a lot of components over here, but it's not, because all you actually need is there's a lot of error handling and rollbacks and things like that. But what all you need to know is that it does a post request, waits for the result URL, and tries to get the response back through the get response. And if it does get, let me show you this again. If it does get a response, it's just going to store the response and send it back to the user, like over here. And that's all that you actually need to do. Let me show you how, like an easier version is that if I look at this fitness chef over here, I have the API integration. This is in JavaScript and that was in TypeScript, but essentially all you actually need to deploy your agent into like a front-end application is this much code.
Could
Everything
we
else
not
is just
could we not do it using Python? Because we are all like talking in Python. I'm curious, like why specifically JavaScript?
like you could actually, because over here we did use in the Copilot kit integration, I did use Python with Fast API. Over there
Uh-huh.
was just everything was in TypeScript, so just stuck with it. But there
Okay.
are like options to obviously use this and then have Fast API and stuff. But I think over
Um,
there it was just easier because the entire application is deployed and self-hosted, and then I'd have to like host Fast API separately and do all that stuff.
okay. Could you show the Python version of yeah,
Yeah.
right on. Yeah. Okay.
So
So
over here,
okay, it's
Python
pretty
is
simple.
even easier. Just headers, your data query, and then you post a request, and then you get with the request ID, and it's pretty simple. And all this is available for every single agent that you deploy. You have the curl as well if you want to like have your post and get through curl. That's also an option. And you obviously have tryout to try out your agent and this chat over here.
And so
Now,
in the try it out is something similar to what you showed in the chat interface?
yes, the
Okay.
try it out would
Sweet.
be just like the Copilot kit integration.
Okay. Okay.
And that's about it.